Now we move into the loop structure. So in the core concepts, we went over the concept of looping, while loops, these kind of things, and we saw this in the flowcharts. Now we're going to see it in pseudocode, and we're going to basically denote this by saying, while a condition is true, do what's in this block of code. And every time the set of instructions are run, then we go back to the top, and if the condition is still true, we run the block again. And we keep repeating that block of code until the condition is false.
So here's a pseudocode representation of that flowchart that we did before, that power function, where we have the while condition, so while c is less than y, increment the counter, and then set our answer equal to a times x. And then once we're done, we return the answer back to the user.
The next type of loop is a do-while, which we've seen before. And so the do-while is very similar to the while, but we do the instructions first and then test the condition. So the way we denote this in pseudocode is by saying do the following block of code with the instructions while this condition is true. If this condition is still true, we go back to the do and execute the block of code again until that condition is false.
So here's kind of an example of doing a do-while loop where we set x equal to 1, y equal to 10, and then we print to the user the value of x and increment x. So while x is less than or equal to y, which is 10, repeat this loop. Now you can see the important thing to note here is that x is consistently increasing, and x is also being used in our decision statement below. So once x equals 10, this statement is no longer true, and then we have printed to the user 1 to 10.
So here's the next type of loop, which is the for loop. And we've also discussed this before, and here's our pseudocode representation of that. The for is a constrained while loop. So we say for the start expression, let's say I is equal to 1, or the counter is equal to 1. A condition that I is less than 10. And an iterate expression is the increment. So I is equal to I plus 1. The start expression, the number, the variable that we start with, our initial value, the condition of when that value is met, and the iterate expression is every time we pass this loop, do this to that value.
So as we kind of described before, you can do the same exact structure with a while or do while, but the for loop contains everything together. So when you look at a while loop and you see while condition is true, the for loop has that exact same thing. It's the middle condition. So the middle condition is what's being evaluated each time that the loop iterates.
So this might be clear in an example.
Yep, here we go. Check this out. Brian, what is this?
So here's an example of a for loop where we set y to 10, and then just like we showed before, we write for, and then in parentheses, x is equal to 1, and that's the starting value. Then the condition that we test, x is less than equal to y. And you'll start seeing this looks just like our do-while example. And then x plus plus means increment by 1 value. So every time this runs, x starts as 1, and then it'll be 2, 3, 4, and so on. And then within the block of code, what we do every time we loop through this is we print x. So this will start out as 1, and we'll print 1. It'll increment x plus plus, it'll print 2, print 3, print 4, print 5, and so on until x is incremented to 11. When x is incremented to 11, we'll evaluate is x less than or equal to y. No, it's not. We'll break out of it and not print.
So this for loop performs the exact same operation that the do while loop did that we just looked at.
Exactly.